Hey guys, welcome to Agro. Paul here. The question of the exploration of the galaxy, it's an incredible question. It's something that's very important to humanity. If you are bound to the Earth, or if it's possible to go beyond the Earth. And some people can think that's just a question of scientific fiction, but it's not. It is actually a question that's really scientific in terms. You can look to the best theories that you have today to find out if it makes sense. And the guy that did this was Alcubierre. He's a scientist, he's a physicist, and he studied a curvature that you need to drive to work. You have a very specific curvature there to drive to work. It's like a bubble, and there is a part that expands and a part that contracts of space-time, and the drive itself is inside that bubble. It's stationary actually, because some people can ask, if you want to explore the galaxy, you need to go fast the speed of light. And I think would say it's impossible, but it's not actually. The drive itself is not going faster than light. What you go faster than light is the space-time, and you know that space-time can do this. Inflation and the expansion of the universe show us the space-time can go faster than light. It's just the options that can't. And so the drive itself is stationary, and the whole system goes. But the part that's really in movement, it's the space-time, this bubble. And Alcubierre found this distribution that's one side that's with equations. You have the other side that's when you put the measure. And the problem is twofold, actually. One is fast extreme quantity of mass, of energy there, and you need at first a lot of Jupiter's mass. There is a more recent paper that they make this much lower, the value there. And so I point out that you don't need negative energy, negative mass anymore. But it's kind of not settled down this question if you don't need anymore. But if you take the approach that you actually need negative energy, negative curvature, we have an example of negative curvature. That is the Alcubierre effect. The Alcubierre effect is effectively like a curvature, negative curvature. But this effect, it's very small. It's a microscopic effect. It is a big question that if you can take this small effect and apply to a ship, so that's massive. It's kind of hard. It's possible that you can do this. And as I said, Einstein is the one that gives us the equation, but he's also this person that showed to us that's very complicated to do this. NASA even NASA actually started research, a little bit of research in this area to find out if it's possible. Because if you can build such a drive, it would be just incredible. Another scientist that's very famous that showed to us that's complicated this area was Hawking. So Hawking, maybe you can build a drive. You don't think this is a problem itself. But when you go to implement this drive, what will happen? In the front of the drive, the bubble, with the accumulation, start accumulation radiation and dust, cosmic dust. And when the person opens this drive and to go out, we have an explosion. So there is a kind of question if you can implement this real drive. Some people can point out, say it's just an engineering problem, but you actually don't know if it's just an engineering problem. You need a more complete theory of the nature of space-time, the nature of curvature, to understand this. Because today we have a theory that's incomplete. General relativity is very good, but have a lot of singularities. Have singularities in some points, specific points. And the singularities show that's a theory that's incomplete. It's incomplete in theory. And because the theory is incomplete, it's not the whole dynamics of space-time. We have in history an example that kind of can give us a guidance, some kind of guidance here. When we started the airplane, the first theory is to create the airplane. Many people say this was impossible, that something heavy the air could fly. Could do this, could it? Was impossible. But after the more theories, more advanced theories about the nature of fluids, was shown that it was possible, and today we have airplanes. Maybe we are in the same position in correspondence to the warp drive. Maybe when we really understand the nature of space-time, can become possible. So it's good that you have heroes. Alcubierre, it's like a hero. He's trying to find a solution to this and create a real Star Trek. Maybe he can, maybe his disciples, his followers can do this, but it's a very good thing that you try to do. Even if you can't do this, probably a lot of good insight and good tools to come for this.